Okay, picking up where we left off, we're on page 612 talking about variance. Variance is a very good measure, but you have to look at the data to see what it means. On the other hand, looking at this next tool called the standard deviation provides me a unit of measure that I can compare. So variance from one data set to variance in another data set, you really can't use those to compare. But the standard deviation, you can. Okay. So standard deviation, so I'm just going to abbreviate that. Okay, so it's a standard deviation, STD, and which one are we going to use? Well, we're going to use the S version, of course. Come on, behave. Here, boy. There. And then light these guys up, just like we've been doing before. Doing. And now I have something that I can use for comparisons. And so that's a pretty tight group there. Standard deviation of 0.04. Let me throw it in percent so you can... We probably shouldn't have used percent here anyway, doggone it. Who cares? Now I can use that to compare other data sets and say, my data set's tighter than yours. No, 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 no. Okay, so standard deviation talks about an easy way to compare data sets if you were so inclined to do so. Okay. The standard deviation can also be used to, a little later on, we're going to use it for determining where a single data point is. For example, you could use a technique to determine if you pick a grade, let's say this grade number right here at 69.1. Is that an outlier? In other words, is that abnormal either at the high end or the low end? Or think of an IQ thing. Somebody comes in and says, well, I have an IQ of 120. Well, is that really, really rare? Or just kind of sort of rare? I mean, how rare is that? So you can use standard deviation to tell you how rare a single data point is in a distribution. Okay, we're not going to do that, but that's what it's for. The next thing we're going to talk about is putting things in buckets. There's a thing called the frequency distribution. Frequency distribution is basically counting things in buckets, okay? But I gotta have some buckets to make this thing work. So I want to go look at the example they have. So here we go. Here's my buckets. Okay, so here's order number and the number of cases of whatever the heck they bought, okay? And what I want to know is I want to count how many had at least 10, how many had at least 20, how many had at least 30. So this is the upper limit. Now it's important to understand that this is the upper limit for a bucket. Now you might be looking at this going, you know, wait a minute, didn't we do practically the same thing using a pivot table? And the answer would be, yeah, we did. Similar. But this is a statistical way of doing the same thing. Now, this is a little weird. Here's how this works. And this is the function called frequency. Returns an array. Now, this is the first time that we've used something by hand that returned an entire array. Okay? I know that sounds a little weird, but just bear with me. So we're going to have to do something a little different. Here's how I'm going to do it. I'm going to highlight all these cells plus one more. Because remember, this is the upper limit. So that means there could be something beyond that. Okay? So I highlight all these cells, but one more than that. Okay. Cool? Whew, here goes. So I say frequency. And then it says, where is the data? Well, my data is going to be the number of cases here. So I just go to do that. Okay, there's my cases. The next one is the array where the buckets are. Okay, well, here's my bucket array. Okay, now I don't select the bottom one because there's no data there. Now here's the part which is freaky as heck. If I was to just hit return here, it kind of sort of would work. But since this thing returns an array, you have to do something a little different. You do Control, Shift, Enter. I know. That sounds a little weird. In fact, you can see what it did. It put that in curly braces. Now, admittedly, you could have typed the curly braces in. You didn't actually have to hold the Control, Shift, Enter. But, hey, that works. So, of these, now you've put things into buckets using the frequency guy. Okay, so it's a pretty cool technique. I remember the things to remember. This is the upper limit on a bin. It does not have to be in any order. Remember when we did the lookup tables? They had to have things in the right order. We don't have to do that here. Although it would kind of sort of make sense. You could have them, you know, the high end or the low end. Doesn't matter which way you start as long as you've got it all in there. Okay. The Control Shift Enter is even called CSE. This is a CSE function. In fact, if you wanted to impress people about your Excel skills, you could say, "Oh, well, that's a CSE function," and they go, "What? You know, woo, you got them right." Okay. All that basically means is it's a function that returns an array, and you have to hold the Control and the Shift and hit the Enter. CSE. Okay. Remember that this thing's always going to return one more than the number of bins you have, so make sure you leave a room for that extra spot. Okay, this is frequency distribution. Okay. Now, let's go back to our other one, where I have a bunch of stuff here, don't I? I've got a whole thing going on. This is the average, the mean, and the mode. Okay, cool. Perhaps there would be an easier way of doing this. Well, believe it or not, there is. There's this add-on called the Analysis Tool Pack, and it's spelled P-A-K for, I don't know, somebody was getting cute. So I'm going to hit Options, go to Add-ins. Hello, Add-ins. Woohoo! Here, boy. Oh, come on. There. Go to my Excel add-ins, and I want to turn on the Analysis Tool Pack. Ding! Okay, now every version of Excel should have this, and it should be the exact same way. So essentially, if I go to Data, I should have this another thing out there called the Analysis Tool Pack. So what I'm going to do is I'm going to click on that, and one of the things is what they call descriptive statistics. Okay, so I'm going to grab that. Then it says, where is your range? I'm going to use the exact same range we've been using so far. Cool. And then it says, where do you want to put the output? Well, I'm going to put the output, I'm going to tell it that I want the output to be right next to ours that we just started. Okay, cool. And then I do want it to show the summary statistics. So I gave it the input range, I told it where I want to put it, and I told it that I want summary statistics. So I hit the button. Boink. And look what it did. It essentially did everything that we did. Okay? It calculated the mean, the standard error, the median, the mode, the standard deviation, the sample variance. The kurtosis is if you can imagine the bell curve. We haven't even talked about the bell curve. If you can imagine the bell curve, this is how squatty the bell curve is or how peaky the bell curve is. In other words, its central tendency, is it really tight, or does it have how many outliers? Okay. Or what percent of outliers? The skewness is the average scooted over a little bit? In other words, if everyone made a B, okay? So not everyone. If most people made a B, well, that's not the average score, is it? That bell curve is kind of scooted over a little bit. So that's the skewness. The range, the minimum, the maximum, the sum. So basically it did everything that we did. Isn't that pretty cool? And it did it all in one step. So this is a pretty cool little tool. Okay, so this is the Analysis Tool Pack. Now, on page 616 and 617, they have one of those quick references, and that kind of goes over what each one of these things mean. And I do want you to know, in general, what each one of these things mean. Okay, I'm not going to ask you, a great deal of information about it, but if someone says, what is skewness, you'd be able to say, does everything line up in the center, or is it squashed over to one side? That kind of stuff. That's kind of what I want to know. What's the symmetry of the data? Okay, so that's a very cool thing, doing the Analysis Tool Pack. Now, remember when we did the bucketizing thing, where we went in there and we did, I guess we'll go back to this one. I hate flipping around, that's kind of weird. Okay, well, the Analysis Tool Pack will actually do this for you, and it'll plot a histogram. Now, why? I mean, how difficult would it be for you, the poor human, to go make a histogram out of this? Not very difficult. But what the heck? It does it for us, so hey, right? So I'm going to go here, and I'm going to go find the histogram on the list. So, and it's almost the same thing. What is the input range? Now, this time I am going to grab the label here, okay? And whenever I do that, I have to make sure that I have a checkbox here where it says labels. And the bin range. Okay, so the bin range is that. And then I'm going to put my output. And I'm going to tell it I also want to do a chart, okay? Right? So where do you want to put this guy? I'll put him right there. So, doing. So what it did is it went ahead and came up with, I missed a, oh no I didn't. Oh dang it, I told it I told it that I had labels and then I didn't select a label. Okay, I screwed up. But anyway, the point, ignoring the fact that it thinks 10 is a label, and therefore messed up the rest of the stuff here, it produced not only the frequency guy, it also produced a histogram of that. And so it's just an extra, it's easy, okay? Hey, I like doing things easy. So histogram is a cool way of doing that. All right, I do like this because I don't have to do that goofy CSE thing. I don't have to do the control shift thing. You know, it's a lot easier, particularly if I've done it right. Okay, the next one they're going to talk about on page 618 is called moving averages. And so the moving averages are kind of sort of like, I've got some data, but there's too much variation in the data, and I want to dampen out some of the noise. Okay, that's an interesting way of describing it. So here's an example of a moving average. Now you could do this by hand, right? But what the heck, right? You got an analysis tool pack, might as well use it. Okay, so here it goes. So this thing in here called moving average. And it says, where's the data? Well, here's it. Doggone it, I am going to select the label this time. Okay. What is the interval? Now, I happen to, so this is like January, February, so my interval would be the moving average over like 3 months. And this is just something you can pick. You know, I'm going to use pick. And then where do you want the output range? Well, I want the output range to be right here. And go ahead and throw a chart in there. Sure, why not? Woohoo! Now, you might look at this and go, oh no, I got NAs. I must have an error. No, you don't have an error. It's just that you told it takes, remember we told it an interval of 3, which means it takes the last 3 pieces of data and uses that to produce a moving average. So the first data point doesn't have enough data, right? Okay, so this is not an error. Now, let's look at what this thing did. I'm going to pull this guy up and make it a little bigger. Okay, what it basically did is it dampened. It's like a shock absorber. It dampened the variation in the data. Okay, so it is the same data. It's just being dampened a little bit to kind of make the hills and valleys kind of smaller and go things. Now, a lot of people look at this and say, forecast? You mean that's what it's going to be? No. The moving average is all historical data. It is not trying to predict the future. You could, if you wanted to, grab a ruler and a marker and go, whoop, here's what I think, but that's not what this is for. So the purpose for a moving average is to act like a shock absorber and to take out some of the variation. So you can see the big picture, the general trend. If you want to know what the general trend is and not be kind of taken by the actual variations in the data, the moving average is an excellent tool for that. Okay, this is a good place to stop for the 15-minute mark. We'll continue this in just a few.